it's got 1 minus it, right?
Right.
So what I'd do is I would use the distributive property and I would multiply this times that part. That way, the dy over dx will be multiplied by each part. Or it will be multiplied by this, but it also, the 1 will be multiplied by this. And I won't have it attached to that 1 minus. I've got to get it to where I got just multiplication with the dy over dx. Then I can do what? Factor out the dy over dx. So, this can just stay just like it is, except, let's go ahead and make it secant squared y, tangent y, dy over dx. Now, is everybody agree it's going to be minus all of this times that 1?
Yes.
So we're just going to get minus cosecant squared x minus y. I just took all of that, minus it times 1. Now, then I'm going to multiply it all times the what?
Derivative.
Negative right there. And so what? Negative times negative is going to make that positive. And then I'm going to get cosecant squared x minus y dy over dx equals 2 tangent x secant squared x. I would try something like O Newton or O Lemnez or O Feynman or O Lighthold. You know,
Because that's what God is.
no, I didn't say that, but he speaks calculus. Now, if you will notice, see this one has a minus sign, and it doesn't have a dy over dx, right?
Right.
I'm going to add it to the other side.
What?
Okay, it doesn't have a dy over dx multiplied by it, does it?
No.
So I want to get it out of here.
Oh, okay.
So I'm going to add it to the other side. Then,
Wait, what did you multiply the dy over dx by? Or did you just
this whole part right here,
and it just equals itself?
well, negative times negative made a positive. And I wrote that. All right? Now, tangent y, dy over dx, I'm not going to combine steps. I'm going to do that to you. Plus cosecant squared x minus y dy over dx equals 2 tangent x secant squared x plus cosecant squared x minus y. Okay, because I've added this one to both sides, right? Now, what are you about to factor out of both of these? Yeah. So you can probably skip a step here because you know it's going to be dy over dx equals everything that's over there divided by the parts that are left after you factor it out. Fair enough? And so dy over dx is going to end up equaling 2 tangent x secant squared x plus cosecant squared x minus y over 2 secant squared y tangent y. Well, I said you should have put those in the same order so they'd look pretty. Plus cosecant squared x minus y. Now, don't you dare ask if I can divide these out. Because they're attached to something with a what? Plus sign. You cannot divide those out. All right? Okay? Please realize if you have a plus b over a minus b, you can't divide those b's out, right? You can't divide those a's out. It's got to be a multiplication. Got a plus sign there. That's just one of those things that if you've done all this work, please don't do that. Now, someone says, Mr. Evans, I looked in the back of the book and that's not the answer. You know why? You could use a trig identity and rewrite that or you could use trig identity and rewrite something in there. But I'm going to see if Lighthole stopped there. I always like to see if we can get to what he has, because that forces us to do a lot of trig review. Number 25, guess what? He stopped right there too.
Oh, yeah.
Yeah, he stopped right there too. And the whole thought is, the calculus step is easy. Yeah, it's all the other stuff. All right. Now, if you look at these, it talks about tangent lines and normal lines, which is all the stuff we've already done, right? But if you get down here, okay, this is all Lighthole up at the top. And this is a modern book because it has the pictures in it of what the graphs look like. Okay? Cardioid, asteroid, and then we have down here this thing called the Devil's Curve. See? And if you want to check, 0, -2 is on the graph, and it asks you to find the slopes of the tangent lines. Now, I keep looking at that and thinking there's a vertical tangent here, a vertical tangent here, vertical tangent, vertical tangent, vertical tangent. Or over here, there's a vertical, but then there's also some what's there? Horizontals. So you start getting into the idea that you could find those too if you wanted to. But this one's cool because he's got pictures with it. Matter of fact, would y'all agree there's a horizontal tangent on this somewhere right there, and there's a horizontal tangent somewhere where? Right there.
Can't you kind of put a tangent anywhere?
Oh yeah,
Yeah.
but I want horizontal ones, so the slope would have to be what? 0, right? Probably there's one somewhere in here where the slope is a +1. There's probably one back here somewhere where the slope's what? +1. Now, so if you wanted to find where the slope equals some number, then you would just set the derivative equal to that number, right? Because dy over dx is the slope. So if I said, where does the slope equal to, what would you put in everywhere you have dy over dx? Put in a what? 2.
You wouldn't plug it in for the x only?
Not if it's the slope. What means slope? Dy over dx. And then you would find the x value.
From the...
Yeah.
Okay.
Now, it could be really nasty on one of these because you're not talking about functions. Oh, notice how we've entered a land now where we can take the derivatives of equations that are not what? Functions. That's a big step here. We've gone from taking the derivatives of everything being a function to the derivatives of them sometimes being a function. Now, if you look at 27, and this is no longer Lighthole, this is Stewart. This is the book you'll be using if you go to one of the top schools around, okay, engineering schools. That's who uses Stewart. All right, x squared plus y squared equals 2x squared plus 2y squared minus x. Close the parentheses, and it's all squared. And they want you to find the slope at 0, 1/2, which is a ponk. Okay? You take the derivative, you put 0 and 1/2 in there, and you solve for the slope. Put 0 in for x, 1/2 in for y. Fair enough? I don't want to do that. I want to find out where you have those horizontal tangents. I want to find, y'all already know how to put the points in there and find the slope, right? I want to find out where there would be horizontal tangents to this thing. And if you look at it, I'm thinking there's 2. And I'm thinking they're going to have the same x value. Is that okay? Horizontal? Going across.
No, I know what it means.
I know I'm being mean. I'm being mean. Okay, I take the derivative with respect to x. So I get 2x plus 2y dy over dx equals. Notice this is a huge what? Power rule. So I put a 2 in. parentheses, 2x squared plus 2y squared minus x, close parentheses, to the power of how much? To the power of 1.
I need to turn my books over.
Yep, probably so. I'm going to erase the words horizontal tangent because I'm about to need the room. Derivative of 2x squared is what? 4x. Derivative of 2y squared is going to be 4y dy over dx minus 1. And that, folks, is the derivative. And then look at the derivative second, make sure you're happy. And to answer the problem that they have in the book, all you do is put a 0 in everywhere there's an x, and put a 1/2 in everywhere there's a y, and solve for what? Dy over dx, and that will tell you the slope at that point. That's too easy. That's just chunk. Y'all can all do that. We're going to look for the horizontal tangents. Now, what's the slope of all the horizontal tangents?
0. Wait,
Yeah.
for that, there, you put the 1/2 on the dy over dx?
The
Or
y.
Okay.
That is not, this is a point. This is a point what? X, comma, y. Now, for what I'm about to do, where am I going to put the 0 in?
dy over dx.
Yeah, but you can't do that yet, because it'll mess you up. Don't do it yet. Did you hear what I just said about not putting the 0 in there yet? Yeah, don't do it. You want to rewrite this to where it's dy over dx first. Okay? Because really, when you have a fraction, what's the only part of a fraction that has to equal 0 for it to be equal to 0 for the fraction? Just the what? Just the numerator. What happens if you make the denominator
It's a
equal 0?
bad
You get
day.
undefined.
Yeah.
Okay. Now, some people say, no, Mr. Evans, you can just put the 0 in there for dy over dx now and work it. I wouldn't do that. I would take my time. All right. If you look at this, it's going to be 2x plus 2y dy over dx. And if y'all don't mind, equals. Now, see this 4x minus 1? I'm going to pull this out, and I'm just going to take the 4x minus 1 and multiply by that. And then I'm going to take the 4y dy over dx by itself and multiply by what? That.
So it can all factor out?
Yeah, that's what I'm trying
So
to do.
you're trying to get the dy over dx on the, okay.
Yeah, I got to get it all by itself. You having a good day?
Yeah.
It's got to come out here and be over here by itself. Now, if you don't like my little trick there, just multiply 4x times all that, multiply this term times all that, and multiply the -1 times all that, and then factor. Still works. Matter of fact, I'm going to do it that way because I can already see the look in your eyes. Multiply 4x times that. Am I really going to multiply it out?
Please do. Show us the trick.
Forget it. All right, I'm multiplying 4x times all that. 2 times 4x, and notice I just wrote that down because I don't want to have to do it all at one time and make a mistake. Yeah, we're past that. Ooh. Now, I'm going to multiply 4y dy over dx times that. 2 times 4 is going to make what? 8. So we'll get 8y. Then I'm going to write down all of that. 2x squared plus 2y squared minus 1. And I'm going to put my dy over dx out here on the end. All right? And then I'm going to multiply minus 1 times all that. So I'm going to get minus.
Why are you only multiplying it by the outside number, not the inside?
Because I don't want to do all that at one time.
He's going to do that next.
Okay, I have A times B times C. Does it matter which order I multiply them in?
No, it's multiplication.
So I'm doing the 4x, and then I'm just leaving that setting there. Because I don't want to try to do all that at one time. I'm not up to that kind of heavy-duty math. Okay? If you want to do that, you go right ahead. Just don't ask me for help if you have a problem. See, I'm a firm believer in allowing you to experiment a little bit. Okay, now, I'm going to take the term, man, Y'all see how I'm gonna take this term right here and subtract it from both sides, so it's over there with dy over dx?
Yes.
And then what we're gonna do with this term that's not with the dy over dx, I'm gonna divide it, subtract it over here, and then I'll have dy over dx equals. Get it to there. Oh, y'all know what to do between, from an hour tomorrow, right?
Right.
Start on what?
3.8.
3.8. Give me an hour on 3.8 derivatives, and we'll get started with that next time I see you.
When are we
Hours
training
is
him
usually
or showing you our achievements?